Okay, so picking up where we left off, in this video we're going to start adding enemies. If you notice, there's some new pictures down at the bottom here. These are the frames of an animation cycle that's going to be used for the first enemy that we add. Now, before we start adding enemies, we really need a way of controlling the game flow, the spawning of enemies and things like that. So we're just going to come up here, go to create empty. I'm going to name this object GM, short for Game Master. It's just going to have a script attached to it, and the functionality to that script really isn't necessarily associated with any one object, and that it's more kind of game flow in general. We'll just slide that off to the side because it really doesn't matter where it is. It's not going to appear on the screen. So let's go ahead and create our first enemy. So game object, create empty. We'll call this pumpkin. Click on pumpkin. Click on animation. As you can see, it says begin animating pumpkin. Click on create. And we'll just call this pumpkin, and we'll call it normal, because it's really not going to have a shooting animation. It's just an enemy that could collide with you. Notice these two objects were created when you did that. So now let's take our pumpkin frames, put them in here. We need to make this slow. Let's make this like 14, and that's just a guess. It might be too fast, it might be too slow. Now, what it is, it's just kind of like opening in its mouth and then closing again. So we're going to have it keep its mouth open a little bit longer. So we'll take that last frame, we'll add it in a couple times, and then we'll come back down the line. Okay, so now if you notice, you don't see it. That's because what you see is whatever the default sprite is at the moment. There's none. So we can go ahead and use the first frame. Really doesn't matter because the animation overrides the sprite. Alright, so that's sitting at 17. That's too far away, so let's bring that to 0. And that's how big it's going to look. So that's a little bit big. So we got a couple things we could do. We can either shrink the pumpkin here or shrink it here. We're going to turn this into a prefab, so in this case it really doesn't matter. So we'll click on pumpkin and we'll make him a little bit smaller. Let's make him like 0.8 by 0.8. That's better. We don't want him to be too big. Now we're just going to run it so you can see it. See how it like kind of pauses when the mouth is fully open? Now we need to start giving him some motion. So we're going to right click, choose create, choose C#, and you can either have a single script that controls all the enemies, or you can do an individual script for each and every enemy. So each enemy gets its own script. Your choice what you want to do. It's a matter of, do you want more scripts or less scripts that are more complex? In a game like this, you really don't have to worry about what kind of impact it's going to have on performance. So it's purely arbitrary. So we'll call this pumpkin ATT. Going to click on the pumpkin again. Going to put pumpkin ATT on him, and that script is going to be used to control him. Now we need to do two things. One, we need to give him motion, so he needs to move from the right side of the screen towards the left. So let's go ahead and open up pumpkin attack. And in the start section, what we're going to do is we're going to give it momentum. But we can't do that until it has a rigid body, just like we did with the witch. So we're going to click on pumpkin, add, physics, rigid body, get rid of gravity. Now it can be given momentum. So, get component. What component? The one we just added, rigid body. What part of the rigid body? The velocity. And what's the new velocity going to be? The new velocity is going to be negative, let's give it -3. That's purely a game balance issue, whatever speed you want them to move at. Maybe you're going to have a difficulty setting that actually changes their speed, so you have less time to react. So what you could do is you could make this a variable and have it change based on the difficulty setting. Maybe we'll look at that in a later video. We don't want it to move vertically. Now, some of them you might want to. Maybe there will be ones coming up from the bottom or the top of the screen. And we don't want them moving on the z-axis. So let's save that. Let's move him off the side of the screen. And now let's watch. Probably a little slow. So, we'll bump that up to 4 and then we'll stop right there. Because like I said, that's really a game balance issue. Okay, so we have an enemy. It moves across the screen, but it's only one enemy. What we need to do is we need to be able to have that enemy appear over and over again. Now, before we do that, we need to look at what's known as colliders. Colliders allow for, as the name would suggest, collisions. So even though there's an image here, a collision doesn't technically get detected by the system. So you have to add what's known as a collider. So in this case, we're going to do physics. Even though it's a 2D image, you can put a 3D collider on it. It really won't hurt anything. So we'll do a sphere collider. And what we're going to do with that is we're just going to shrink it in a little bit. We don't want it to be that unforgiving. And now, for her, we're going to give her a collider. Let's also give her... yeah, we'll go with the sphere. And it's very important also they need to be triggers. So that should be a trigger. That should be a trigger. Now we're going to click on the particle system here. This can also have a collider on it. Now, we'll add, and again we'll just do physics sphere collider. Let's take a quick look to see what that looks like. That's perfect. So the tail won't do any damage, only the front here, but that's fine. Again, this is really just meant to be the broad strokes. You can fine-tune it however you want. So now everything has colliders. Actually, once again, that needs to be a trigger. So as you noticed, even though it's already a prefab, you can still make changes to it. All right, so let's take our pumpkin, drag and drop it down here, delete it from the scene, and now we're going to create a GM script. So right-click, create, and it's going to be a C# script, and we'll call this game flow. Click on the GM, put game flow on it. So what we're going to do is, using transform variables, as I mentioned before, you can make one object aware of another by using a transform variable, and that will allow the GM object, by way of the game flow script, to manipulate these objects. So in this case, it's going to summon the pumpkin. So let's open game flow. So, public transform pumpkin obj. Save that. Click on GM. And there it is. So now take your pumpkin object, put it there. And now what we're going to do, this will just be temporary, just so you see how this works. We'll come back in a minute. We'll have this spawn in the stop, but we'll move it into the update area. So when we're done with the test. So instantiate. So what are we instantiating? We're instantiating the pumpkin object. Where are we instantiating it? We'll, for the moment, use pumpkin object's default position. So if you notice, when you click on the pumpkin object, these are the positions, these are the coordinates it was at when I had it in the environment. So it's going to use those because I said to use its default position. But we're going to change that again when we're done with the test. And we want to use the pumpkin object's rotation. So I think I mentioned this in the last video. What has been instantiated, where it's been instantiated, and what's its rotation. Save that. Run it. There we go. Now nothing happens with the collisions because we haven't coded anything. So that's how you create an enemy, and that's how you instantiate it. Now, what you do as far as like formations and choreography of the enemies, what you do is you put timers in here. And at certain time, the object will appear at a certain location. So if you want it to be random, that's the easiest one. If you don't want it to be random, if you want it to appear at exactly the same places every single time, then that takes a little bit more coding, because every single interval you have to say exactly where it's going, rather than just plugging in a variable and saying it's at a random place. You would say, okay, at half a second it's here, at 1 second this one appears somewhere else, at 1.5 seconds a different one appears somewhere else. So that kind of choreography where it's the same every time does take more coding. More tedious, but again, you can precisely choose where it is every single time. So let's create a new variable. So public and we'll call this public float, public int rand, short for random, and it's really the y coordinate that we're changing. So random y COOR. And now what we do, we take this, take it out of the start section. Like I said, that was just for the test. I'm going to put it here, but then we're going to make some changes. So and again, this won't be the final form. This will also just be a test. So we're going to do random y coordinate equals random dot range, and you have to specify what the range is. So since it's y coordinates, we want it to appear somewhere from the bottom of the screen towards the top. So it's going to be something like negative, I think we said the bottom was somewhere around 3. So we'll say negative 3, comma positive, we said 5 is near the top. So with every frame, it's going to choose a random number. Now that's more than what we want, but again, this is just to start with. Now we need a delay, so we're going to need another variable. So public, and we'll make this a string. And we'll call this spawn delay, and it will start off at the letter N for now, that it's not delaying. So now we'll wrap this up into an if statement. So if spawn delay equals no, then we want something to spawn. And this is going to determine where it spawns. And since we said we need a delay, spawn delay also gets set to Y. So at the beginning, spawn delay is equal to no. If spawn delay equals to no, go ahead, generate a random number, and then we need to instantiate the pumpkin. We're going to change the position in a minute, and then set the delay. So then this will not happen again until this gets changed. So we'll do that in a minute. We just need to fix this first. So now we actually break this down into its 3 coordinates, its 3 vectors. And we're still going to use, we want to use the pumpkin's default position for x. So transform.position.x, but the y is going to be that random range. So as we said, that's why we called it random y coordinate. And then the third coordinate will also be, actually we can just put it at 0 to be honest, because that's where the pumpkin is. As you can see, z is 0, so 6 one way, 1/2 dozen the other. You can either put in 0, or you can do transform.position.z there. Now that should do it. Now what we need is we now need this to get changed after a amount of time has passed. So, i.e. numerator, and we'll call this reset spawn timer. And it's just yield, return, new, wait 4 seconds, and we'll have 1 second between each spawn. And that's when this gets set back to no. Why? So what's going to happen is we haven't finished yet, but this is going to get set to yes, so no more gets spawned. We wait 1 second. This gets set back to no, making this true, and another enemy gets spawned and gets set back to yes. So the only thing that's missing is this section actually coming down here, because this won't ever execute on its own. You have to specifically tell it to come down here, whereas start executes on its own, void update executes on its own, i.e. numerator does not. So how do we do that? Start coroutine, parenthesis, and then the name of your coroutine, also with its parentheses. Done. If I didn't forget anything, that should do it. So one last time, at the start, this variable is equal to no, so that means this is true. It will perform everything in here because it's true, including setting this to yes, meaning that it won't do this again until it's true again. And go ahead and start the coroutine. Comes out to the coroutine, waits 1 second, changes this. Oops, sorry, that should be N, not M. My apologies, it wouldn't have worked. And with this being set to N, this now becomes true, and now it's just rinse and repeat so long as the game runs. Let's actually change this. Since it can appear in the same X location, we don't have to be that fancy. There we go. Now, not as much range as I would like there. It's all kind of gathered together. So first of all, let's increase the delay. If you use a fraction, you have to, or a decimal, I should say, you have to add the letter F or else it gets confused. And let's have this range up to 6 and be down to -4 and see how that looks. There we go, so that's higher. Okay. All right, I think we're going to stop there. So we have our spawning enemies. In the next one, we're going to look at collision detection. So we already created the colliders. Now we're going to look at, or should I say, next video, we're going to look at when she shoots out this spell about working with the collisions and about when they collide with her. Okay, so that should do it for this one.